Good morning. Today we are going to start with Unit 3, which contains stacks and queues. So let us start with the stack first. So in this particular session, we are going to focus on what is stack, what are the characteristics of stack, then what are the examples of stack as an ADT, then primitive operations that we can perform on stack, then describe the stack using arrays, sequential organization, and describe the stacks using linked list, that is a linked organization. And lastly, applications of stack. So let us start with the session. What is stack? So before we go into the technical details, you can see the diagram. It is a list of plates. Plates are put over one another, right? Similarly, in the next we have a list of chairs. Chairs are piled over one another. So stack is actually when you put elements one over the other, it is called as a stack. In the stack, if the elements are organized in this manner, then it is not possible. As we can see, it is not possible to remove any chair in between from in between position and to put any chair at in between position, right? If I have to remove a chair, I have to remove the chair only from the top. Similarly, if I have to insert a chair, I can insert only from the top position, right? So the stack has its own rule called as last in, first out. In short, LIFO. So see which chair is put on the last, that is on the top, and which chair will get removed first, which is on the top. So the element which is pushed last will get popped first or removed first, right? So data can only be placed on the top of the stack. Data can only be removed from the top of the stack. Data can be removed from the bottom of the stack if there is only one atom in the stack, right? Suppose if you remove all the chairs and there is only one chair remaining, then top bottom will be the same, and then you can remove from the bottom as well. Data cannot be removed from the middle of the stack without first removing all the atoms from the top. So basically, what is stack? Stack is a data structure which follows a rule called as LIFO, that is last in, first out. Okay. For example, stack of coins, stack of plates, stack of chairs, tower of Hanoi, and so on. There are so many applications of stack that we go through in our day-to-day life. Now, what are the primitive operations that we can perform on the stack? So to create a stack, to insert an element onto the stack, to remove the element from the stack, to check which element is on the top of the stack, to check whether stack is empty or not, to check whether stack is full or not. These are the primitive operations. Now let us talk about stack as an abstract data type, that is ADT. So abstract type def, element type, stack with element type. Then abstract empty stack, stack element type S, and the post condition for it is empty is equal to length of S is equal to 0. That means if your length of stack is equal to 0, we can say that stack is empty, that there are no elements. Then abstract element type pop of S, the pop operation. Stack element type of S is your input. Precondition, stack of S is equal to false. Empty of S is equal to false. That means you have to check a precondition before pop that stack should not be empty, and the post condition is that pop is equal to first S1 and S is equal to sub S1 comma 1 comma length of S1 minus 1. It means that you can pop the element which is at the first position, at the topmost position, and once you pop the element, you have to update the top, okay, to the next position. Then abstract full of S. Here you have to check whether stack is full or not. So post condition is full is equal to length of S is equal to max. If your stack is containing all the elements, okay, it's up to its limit, then you have to say it's a full. Then push, the push function, abstract push S comma element. So stack element type of S, and then element type ELT, the element variable, and then precondition, you have to check the stack should not be full. If you want to push some element, insert some element into the stack, you have to check it should not be full. If it is full, you can't push the any more element. And the post condition is that S is equal to element plus S1. Means what? You have to push your element onto the top of the stack, and you have to update the top by 1, incremented by 1. And one more is there, abstract element type top of S. You have to check which element is available on the top position. The input is stack EL type S. Precondition is that empty of S is equal to false. Stack should not be empty. And post condition, you will get the element on the top. So top is equal to first of S. Whichever is the element on the top position, that will be written into the top variable. So this is stack as an ADT. Now let us see these functions, how they work. So first is to create a stack. So this function creates a stack in memory. Creation of stack can be either using array or linked list. Now stack can be implemented by using a sequential organization of arrays, or it can be created with the help of linked organization, that is linked list. We are going to focus on both of them. So to insert an element onto the stack, this function insert a new element on the top of the stack. Insertion function is referred as push in case of stack. So push, and you have to pass which element you are going to push, that is E. Okay, so this function which places element E onto the stack, top of the stack, if stack is not full. Then to remove the element from the stack, this function deletes or removes element from the top of the stack. So pop function is there, a function which takes out an element from the top position of the stack if stack is not empty. To check whether stack is empty or not, so stack full function, it is a boolean function which returns 1 if the stack S is full, and stack empty, a boolean function which returns 1 if stack is empty. Now let us see a program to implement stack using array. So we will have hash include iostream.h, our header file. Then we will define a size to 5, and let us define a class stack. And there is, I'll take array S of type integer of size S. So this array S will hold 5 integer elements at size is 5. I need to declare a top also, so I'll declare integer top. Then in the public section, let us declare the functions. So we will have one stack constructor. I'm going to take a default constructor with no parameters. Then the function is full. Is full is going to return 1 or 0 depending upon whether stack is full or not. So return type will be integer. Then is empty. This function also returns 1 or 0 depending upon it is empty or not. So return type is integer. So integer is empty. Then void push, integer element. So full push function does not return anything. So return type is void. And integer element, which element I want to push, that also we need to pass. Then integer pop function will just pop out the element, remove the element which is on the top. It will return that element which it has popped out. So return type is integer. And integer read top. So read top function is going to read which element is on the top and return you that. So return type is again integer. Now let us define each function one by one. So start with default constructor. So default constructor, no return type, stack is my class name. I'm defining it outside the class. So scope resolution operator and stack, the constructor name. Here I will declare top is equal to -1. That's it. Because I'm creating the stack for the very first time. I'm creating this object for the very first time. So top is going to -1. No elements are there. So it indicates that your stack is totally empty, right? So you have created an empty stack which has top is equal to -1 with the help of this default constructor. Then I will write down another function is full. So it returns integer, so integer, then name of the class, then scope resolution, name of the function. Okay, and this define it. If top is greater than size -1, then you have to return 1, else you have to return 0. Means what? Right now my size is 5. So if my top becomes greater than 5 minus 1, that is 4. If your top becomes 5, then in that case you have to return 1. It indicates that size of the array is full now. You cannot push any more element, right? So you have to return 1. And if it is 1, then it indicates stack is full. Similarly, stack empty condition is empty. So if your top is equal to -1, then you have to return 1. Otherwise return 0. It indicates top is equal to -1 means your stack contains no elements. It is totally empty. Then next function push. Void stack, scope resolution, push, and we have to pass the element which we are going to push onto the stack. So what you have to do when you want to push onto the stack, you just have to say top plus plus. Okay, so you have to increment the top by 1. So you'll get a new top, and at that position you have to push your element. So top plus plus, and then s of top is equal to element. There you have to place your element. Similarly, pop function. So I will require one variable, temporary variable, say element. So what I will do, whatever is the value on the top, so s of top, this value I will take and I will put it into the element. Okay, so I have popped it. After that, what you have to do, top minus minus. So you have popped the value on the top. Now you have to decrement the top. So top minus minus, and you have to return which element you have popped just now. So return element. Then last function, read top. So integer stack, read top. So it will return what element is on the top. So return s of top. So this is very simple implementation of array using, implementation of stack using arrays. So we can implement the stack using linked list also. So what is the need of implementation using linked list? So we all know what are the standard drawbacks of arrays. So same are applicable here in stacks also. So size is restricted, right? So we need to declare beforehand of the size of the array, and only that many elements we can push onto the stack, or we can store onto the stack. Similarly, if we declare an array of 100 elements, and if we store only 10 elements in the array stack, then rest of the 90 elements memory will be wasted. Okay. So for overcoming these disadvantages, we will use representation of stack using linked list. So when we use the concept of linked list, nodes are created dynamically, right? As it is needed. So we will not check memory full condition over here. So see, in case of arrays, we have to declare the size of the array, say 5, and only 5 elements can be pushed. So at one point time, array full ka condition will be there. But here in case of linked list, we are going to create the nodes dynamically. As and when we have to push an element, we will create a node. So memory full condition will not occur, and stack full condition, there is no need to check that particular condition. Let us talk about stack using linked list now. So let us create a structure for stack, struct stack. As we are going to use linked list, so linked list is nothing but a set of nodes, and every node contains 2 elements. One is a data, okay, and the second one is a pointer to the next node. So first is here integer data, and second one is here struct stack star next. So next is a pointer which points to the next node, right? And we will create a structure variable node over here. Now representation of a stack using linked list, simple editing. So we will check is empty condition. If top is equal to null, right? Then we can say that list is empty. Is full condition, this is not applicable for linked list implementation as we create dynamically. Push, it is similar to insert beginning of SLL. Yeah, in this case we are using single linked list. So this particular push function is similar to insert at beginning in the single linked list. Is empty, then top is equal to current node. Okay, else insert at the beginning. So if your stack is empty, then you have to say top is equal to current node. Whatever new node you are going to insert, that will become the top. Otherwise, you have to call the insert beginning function or that logic. Then pop function, it is similar to delete beginning of single linked list. So you are going to check if is empty, then do not call the pop function. Okay, if stack is already empty, we can't pop anything from it, so don't call it. Else, if the stack has some nodes, then what you have to do? The last node, if the last node, then top is equal to null. Yeah, one more condition. If the stack contains only one element, last node, then you have to say top is equal to null. Pop that and say top is equal to null. Otherwise, you have to call delete beginning function. So let us see implementation of stack using linked list. So class stack, and then inside that we will create that structure node. It will contain integer data and node star next as a pointer, and we'll create a structure variable of type pointer, say star top. Top will always point to the top element on the stack. Then let us declare functions. Stack is my default constructor, void push function with one parameter which we are going to push, then pop function and is empty function. Is full function is not applicable here. Let us define the functions one by one. So default constructor, I'll just say top is equal to null, right? If you remember, in array we have said top is equal to -1. Here we have to say top is equal to null. If top is equal to null, you just have created this particular stack and it contains no elements. Then let us define the push function. Void stack push integer x. X is the element which we are going to push. So first of all, we have to create a node which we want to push. So node star new node is equal to new node. So I'll create a object, okay, of that node. Then new node of data is equal to x. Whatever you have passed into the push function, that data will become nodes data, new nodes data, right? And then new node of next is equal to null. So I'll create a new node containing x and null because it is not pointing to anything. First node is created. Then if your top is equal to null, that means if this is the first node on the stack, that means your top is null, then what you have to do? Top is equal to new node. On the top, you have to put that new node. Else, if the stack contains some elements, then what you have to do? You have to say new node of next is equal to top, and then top is equal to new node. Okay, so new node's next pointer should point to the top now. Okay, and your new top will be new node. Is empty condition, you have to, if your top is equal to null, then you have to return 1. So it indicates is empty condition. And in case of pop function, let us define one variable, say x, which will hold your popped element. So what you have to pop? Top of data, right? And you have to put it into x. So x is equal to top of data. Then define one temporary variable, node star temp, and make it point to top. So node star temp is equal to top. So temp will now point to top. Then you have to do top is equal to top of next. You have to decrement the top. So top will point to the next element which is in a list. And then you have to delete the temp, right? Temp was pointing to the top and you have removed the, you have decremented the top now. So whatever the element the temp is pointing, that you have to delete. You have to set it to null also, and then return x. So x will contain the value you just popped out. So concept of implicit and explicit stack. So implicit stacks are nothing but they are used by runtime memory environment. They are used to store the function called status. Programmer cannot manipulate the implicit stack, for example, function calls or recursions, right? And then explicit stack. Programmer designs his own stack. The way we have designed our own stack, that is a explicit stack. So implicit stacks are built in. They are used in function call and return. They are used in recursion. Whereas explicit stacks or push pop functions are called by the user. Okay. For example, in assembly language also. Then implicit stack, objects are created, push and pop functions are called implicitly by the system during recursion or function calls. In case of explicit stack, objects must be created, push and pop functions are called manually by the user. For example, any stack operation like say reverse string. Then the concept of multi-stack. Suppose there is an array of size n. We can divide it by 2, then it will become n by 2. Now there will be two sub-arrays, right, of size n by 2. So first half of array is stack 1 and second half of array can be stack 2. So in this case, top 1 and top 2, there will be two top. Top 1 will point to stack 1 and top 2 will point to stack 2. Now top 1 is equal to minus 1 and top 2 is equal to n by 2 minus 1 in case it is empty. Now if top 1 is equal to minus 1, stack 1 is empty, and if top 2 is equal to n by 2 minus 1, stack 2 is empty. And in case top 1 is equal to n by 2 minus 1, that means stack 1 is full. And in case top 2 is equal to n minus 1, that means stack 2 is full. Okay, so we can use a single array and we can implement multiple stacks on that also by managing the tops. Now last is what are the different applications of stack. So we can use the stacks for expression conversion. Like there are three types of notations by which the expressions can be represented: infix notation, prefix notation, and postfix notation. So we can convert infix to postfix, postfix to prefix, and so on with the help of stack. Then expression evaluation. You can solve or evaluate expression with the help of stack and you can find out the result. Reversing a string, tree traversals like in order, pre-order or post-order. Then similarly graph traversal, depth first search, checking if expression contains balanced parentheses or not, the undo button, the back button of your browser, and so many applications are there where stack is used as an internal data structure. Thank you.